The solar system is just a speck of dust against the backdrop of giant galaxies and star clusters. There are thousands of stars within 100 light years of it. Some of them are barely visible against the cosmic abyss. Others shine so brightly that they can even be seen from other galaxies. There are also many invisible objects hidden in the depths of space, from massive brown dwarfs to rocky exoplanets comparable to Earth. Some of them can awaken the spirit, while others are threatening. But all this diversity pales in the scale of the galaxy. At least 200 billion stars and more than 1 trillion planets are hidden in its depths. Such a number of unique space objects cannot be fully explored. So let's talk about the closest ones. By galactic standards, the region of space adjacent to the solar system is considered lightly saturated with both luminaries and other cosmic objects. However, about 50 star systems within 15 light years of Earth are already known. Some of them are individual bulbs. Others contain 2 or more components, so the total number of stars in this region is 65. Many of them have exoplanets and protoplanetary disks of gas and dust where the process of formation of celestial bodies continues. To explore all this diversity, we need to create a map of our immediate surroundings. Gradually leaving our home planet, we cross dozens of light years into the cosmic void and visit many distant worlds. It's time to head for the stars. 6 light years from the Sun, we reach our first target, the small red dwarf GJ 699, also known as Barnard's Star. It is remarkable because it moves across the sky at an incredible speed and can cross the lunar disk in 180 years. This is due not only to the short distance to the target, but also to the very fast proper motion of the star. The Flying Barnard is approaching the solar system at just over 100 kilometers per second, and in about 10,000 years, it will be the closest star to us. So far, the distance between it and the Sun is only 3.8 light years. But even at this distance, the faint glow of the red dwarf is not enough to be seen without optical instruments. The mass of the star is only 17% of the solar mass, and its radius is about 6 times smaller. Like all red dwarfs, the Flying Barnard is pretty cool. Its surface temperature is only 3,134 Kelvin, just below 2,900 degrees Celsius. According to this information, it is not surprising that the luminosity of the object is 2,300 times smaller than our star. In 2018, the results of a 20-year observation of the star's own motion were published, which could provide evidence for the existence of a nearby exoplanet. Available calculations indicate that it is a cold super-Earth with a mass of at least 3.2 Earth masses. The planet, dubbed GJ 699b, is located about 0.4 AU from the center of the system and completes a full revolution around its parent star in 233 days. Unfortunately, the exoplanet's orbit is located so that it does not pass between Earth and its parent star. Therefore, it is almost impossible to perform a spectral analysis of the target. However, mathematical modeling may give us clues. Because Barnard's star is so dim, its planetary companion receives 50 times less energy from the Sun than Earth. That is why the surface temperature of the celestial body is very low, only 105 Kelvin, or minus 168 degrees Celsius. However, it cannot be ruled out that tidal disturbances or radioactive decay have released enough energy in the planet's interior to form a warm underground ocean. If this is true, potential life in its depths has had plenty of time to slowly evolve. Indeed, among known luminaries, Barnard's star is probably one of the oldest. It is estimated to be more than 10 billion years old, which is only a few % of the expected lifespan of a star. Barnard's star is one of the most important targets of possible interstellar missions because of its proximity and favorable direction of motion. Only time will tell if an artificial spacecraft will ever be able to reach it. Meanwhile, on the other side of the Sun is almost the exact opposite, a dim red dwarf. We're talking, of course, about Sirius, the brightest star in the night sky, located 8.6 light-years from our planet. On Earth, this bulb looks like a single light source. However, a closer look reveals that it is not a single object, but a double star. Currently, the two parts of the system are at their greatest distance from each other, about 30 AU. The main luminary, also called Sirius A, is a bright blue-white star with twice the mass of the Sun. In addition, its diameter is 70% larger than that of the Sun, and its surface temperature reaches 10,000 Kelvin. This allows Sirius A to emit 25 times more energy than our star. The second object, known as Sirius B, is barely visible against its bright and massive companion. It is a white dwarf with a radius of about 6,000 kilometers and a mass very close to the solar mass. Like all stars of this type, its surface temperature is very high, reaching 25,000 Kelvin. However, because of its small size, this white dwarf is about 1,000 times dimmer than its stellar companion. After a long and persistent study, no signs of planets have been found in the vicinity of Sirius. The reason for this may be either the young age of the star system or the special position of the ecliptic plane. Consequently, hypothetical exoplanets do not travel between the light source and Earth, so they cannot be detected by the transit method. Another hypothesis states that about 120 million years ago, Sirius B ran out of stellar fuel and became a red giant. Shortly thereafter, it shed its outer shell and transformed into a compact and extremely hot white dwarf. The resulting explosion destroyed the protoplanetary disk of gas and dust that surrounded the young star system at the time. Its remains are scattered in the surrounding space, leaving the ascending planets a chance to survive. Currently, both parts of the system move around a single center of mass in moderately elongated orbits, making a complete revolution every 50 years. Over the next 60,000 years, Sirius will gradually approach Earth, becoming brighter and more visible in the night sky. The minimum distance to it is about 7.5 light-years, after which the system begins to slowly drift away from us. This situation will continue for another 660 million years, after which Sirius A will suffer the same fate as its companion. In a short time, a powerful flare increases its luminosity 1,000-fold, but in a few months, the star will completely fade away and disappear from the sky forever. Leaving the vicinity of Sirius, full of destructive ultraviolet radiation and stellar winds, we will travel close to the solar system to reach a small star 14 light-years from Earth. It is known in several catalogs under different names, one of which is Wolf 1061. The luminary is a red dwarf with a radius about 30% of the Sun. Its mass is about 4 times smaller than our star, and its surface temperature is 3,272 Kelvin, or about 3,000 degrees Celsius. Like all objects in this class, Wolf 1061 is extremely obscure. Its luminosity is only 0.14% of the solar luminosity, so the star cannot be seen with the naked eye from Earth. However, this red dwarf has one of the most abundant and diverse planetary environments in our nearest star system. At least 3 exoplanets have been discovered in its vicinity, all of which are rocky and similar in composition to Earth. In addition, the conditions of all 3 celestial bodies differ significantly. The first and closest exoplanet to its parent star is called Lupo 1061b. It is located at a distance of 0.038 AU from the center of the system and makes a complete revolution around it in about 5 days. The mass of the object ranges from 1.5 to 2 Earth masses, and the radius it is 20% larger than the corresponding parameter of our planet. The celestial body is believed to be tidally locked and is constantly on the same side of the star. So the temperature on the day side of the object is very high, and the rockets and stellar winds of a nearby star virtually preclude the existence of an atmosphere. All these factors make the exoplanet completely unsuitable for the formation and maintenance of life. The second object in the system, Wolf 1061c, is located at a distance of 0 to 0.089 AU from the star and makes a complete revolution around it in about 18 days. Thus, it is in the habitable zone of the star and can be considered a potentially habitable celestial body. Wolf 1061c is about 4 times more massive than our planet and is categorized as a super-Earth. Observations show that its radius is about 1.6 times larger than Earth's, and the gravity of Earth's surface is calculated to be 60% greater than what we are used to. An exoplanet receives much less energy from its star than Earth receives from the Sun, so its equilibrium temperature is much lower. It is 223 Kelvin, or about minus 50 degrees Celsius, which is slightly warmer than Mars. However, due to daily and seasonal temperature fluctuations, liquid water may be present on the surface of the celestial body. In a dense atmosphere with a strong greenhouse effect, this probability is even higher, and conditions on the planet may approach comfortable. Of all the currently known potentially habitable exoplanets, Wolf 1061c is one of the closest and ranks 5th on the list. The third object in the system is known as Wolf 1061d. It moves in a remarkably elongated orbit. At its farthest point, the distance between the planet and its parent star reaches 0.73 AU. The perihelion of the orbit is much closer to the center of the system, only 0.21 AU. At the same time, the annual cycle of the celestial body lasts about 217 Earth days. Wolf 1061d is calculated to have a mass of about 7.7 Earth masses. If this celestial body is a rocky object, its radius will be about 1.7 terradius. If the planet is a mini Neptune with a thick multi-layered atmosphere, its diameter should be at least 2.2 times the diameter of our planet. Despite the relatively high eccentricity of its orbit, Wolf 1061d will never reach the habitable zone of its star. This system is one of the main targets of future research, so new discoveries are likely to be made soon. The star Lupo 1061 is known, among other things, for being located almost at the edge of the so-called local interstellar cloud. This is a region of space filled with hot but extremely rare hydrogen. Its temperature is about 7,000 Kelvin and only 0.3 atoms per cubic centimeter of space. It is about half the average size of the Milky Way. Over the past 10,000 years, the solar system has been moving through the local cloud. Its average diameter is about 30 light-years, but our system is almost at its edge. Alpha Centauri, for example, is already in the nearby so-called G-cloud. We spend another 2,000 years in our cloud, A, after which we enter even rarer and hotter territory. The local interstellar cloud was formed by the collision of two giant bubbles of hot cosmic gas. It has its own momentum directed perpendicular to the direction of motion of the solar system, as well as a magnetic field and radiation. Despite the high energy of the interstellar gas particles that make up the cloud, there is no threat to Earth's organisms. The solar wind shields us safely from the cosmic hydrogen, and the Earth's dense atmosphere absorbs the effects of those particles still breaking through the heliosphere. However, traces of the isotope iron-60, also called interstellar, have been found in Antarctic ice. It is said to have been brought to Earth from a local interstellar cloud. Continuing our journey through outer space, we soon discover a rather unusual star called AP Dove, located 27.4 light-years from Earth, at a time when the dinosaurs were extinct on our planet. Even more surprisingly, the event occurred in a completely different region of the galaxy, 450 light-years away from the object's current location. Usually, young stars stay near their stellar cradle for quite a long time, up to several hundred million years. Analyzing AP Dove's proper motion shows that it was probably once part of the scattered cluster IC 2391. It contains about 30 stars that share a common origin and direction. But a few million years ago, one of them exploded, upsetting the delicate balance of many cosmic bodies. Being a very small red dwarf with a mass only 13% of the Sun, This star emits 4 times more energy than any other known celestial body with the same parameters. In addition, its radius is 2 times larger than the value calculated by the current theory of stellar structure. Strangely enough, finding answers to these riddles helped us to find another unusual feature of the star. Indeed, according to a spectral analysis of its radiation, the stellar matter of the AP Dove contains an extraordinary amount of lithium. Usually, this element is abundant in protostars, but it burns up quickly once fusion begins. This means that it is a very young star, not yet in the Premier League. Consequently, AP Doves is characterized by instability and explosiveness. It undergoes strong flares and ejections of stellar matter, during which its brightness can increase tenfold for an instant. However, observations show that there are no large cosmic objects within 4.5 AU of this star. Apparently, its age is too young to form full-sized planets. However, it is a unique cosmic body that is very important for understanding the process of early stellar evolution. As we've seen, not all stars have planetary systems, so our next stop is the orange dwarf Gliese 370, located 37 light-years from Earth. In 2011, the exoplanet Gliese 370b was discovered nearby. The object was found using the radial velocity method, and its mass is 4 Earth masses. Under these conditions, the gravity on its surface must exceed our normal gravity by at least 40%. Gliese 370b is located at a distance of 0.26 AU from its parent star and completes a full annual revolution in 54.4 Earth days. Thus, the exoplanet is in the habitable zone of its star. If the value of albedo and its surface is close to the Earth's value, the average temperature of the celestial body should be approximately 25 degrees, which is a few degrees higher than on Earth. The fact that the exoplanet is located far enough away from its parent star suggests that it is not in a tidal grip and has its own diurnal cycle. This contributes to a more even distribution of heat on the surface of the celestial body, and, as a consequence, may cause a milder climate. The moderately high gravity should smooth out the planet's topography, which, combined with the abundance of liquid water, could cause the formation of spacious seas that are warm and shallow. Such places are traditionally considered the most convenient for the creation and preservation of life. At the time of its discovery, Gliese 370b was considered one of the most attractive exoplanets for possible biological life. However, subsequent research suggests that conditions on its surface are a bit more uncomfortable than previously thought. In particular, it is possible that the atmosphere of the celestial body is too dense and has a strong greenhouse effect. However, even according to the most pessimistic predictions, the average surface temperature of the object does not exceed 78 degrees Celsius, which corresponds to a temperature difference of about 100 degrees. Given that our planet's climate was about the same during the Archean, Gliese 370b remains a very attractive exoplanet for the search for extraterrestrial life. This means that its research continues. If we stop for a moment and look around, we realize that we are already more than 50 light-years away from the solar system. There are more than 1,000 stars in this radius, most of them single stars. Other objects are twins, or even represent entire constellations. The most obvious example of this is Custer, a complex, amazing system with 6 components at once. This star system is located 50 light-years away from Earth and is visible to the naked eye as a single light source. As the second brightest object in the constellation Gemini, and the 23rd object in the entire starry sky, Custer has been known to man since ancient times. Since the system has up to 6 components, its structure is quite complex. The 2 brightest of them, Castor A and B, are blue-white luminaries similar to Sirius, each with a neighboring red dwarf. The distance between the centers of mass of these twin stars is approximately 110 AU, and a complete revolution takes 445 years. About 600 AU from wheels A and B, is another close double system consisting of a pair of very similar red dwarfs. Both stars have a mass of about 0.6 C and a surface temperature of about 3,900 K. The two stars are so close to each other that their rotation takes less than 20 hours. They move around the common center of mass of the entire system in a very elongated elliptical orbit with an orbital period of about 14,000 years. No confirmed exoplanets have yet been found in the Custer system. However, if there are any, they are most likely to be found here, near the faintest component of the system. For example, in 2018, astronomers discovered changes in the orbital period of Custer C that suggest there may be a brown dwarf about 49 times more massive than Jupiter nearby. It is calculated to be 14 AU away from its parent star and completes a full revolution around it in 54 years. It is quite possible that, like many red dwarfs, C of Custer has rocky exoplanets near its star. In this case, the view from the sky of such a hypothetical point must be truly incredible. On one side, much of it is illuminated by two continuously rotating crimson lights in the sky, and on the other side, the light from hundreds of stars breaks the eternal darkness. Times brighter than Earth's moon. Really? I can't verify it yet. Although the lights we visited are separated by vast distances, they are all part of a single structure with a total length of about 300 light-years. Called the local bubble, it contains not only thousands of stars, but also several large structures, including the local interstellar cloud. The local bubble was formed by the successive explosions of several supernovae that occurred between 10 and 15 million years ago. It's a giant cloud of interstellar gas, heated to 1,000,000 Kelvin. Because of its high temperature, the gas tends to expand, making it about 10 times less dense than the galactic average. In addition, hot ionized hydrogen continuously emits X-rays. However, the magnetic fields of the Sun and Earth and the planet's atmosphere successfully protect us from harmful radiation. The local bubble is confined to other similar settings. For example, the so-called Bubble 1, formed by supernova explosions near Antares, is somewhat out of the solar system's path. This giant cosmic structure interacts with our bubble for a long time, causing huge condensations in the bordering region. The center of the neighboring bubble is about 500 light-years away from us, and in a few tens of millions of years, the solar system will reach its edge, hot gas clouds and scattered clusters, giant nebulae and star streams. All these majestic cosmic structures form single systems called galaxies. These, in turn, merge into galactic filaments, giant streams and walls, billions of light-years long. Thus is formed the large-scale structure of the universe, hiding in its depths countless different lights and worlds. Who knows what we'll find in them?
Mars. An attentive observer looking at the starry sky will see a small reddish round spot. This is Mars. This object attracts attention with its mystery and constant hope to find the very thread that will reveal the great mysteries of the universe. The parameters of the planet. The first known observations of celestial neighbors were made during the time of the pharaohs in Egypt, 1,000 and 1,500 years before Christ, to determine the planet's position in the sky between Earth, the asteroid belt, and Jupiter. Mars is one of the planets in the solar system, located in the fourth orbit after Earth. Mars revolves around the Sun in an elliptical orbit with a very significant eccentricity of 0.934. Therefore, the distance between them during the revolution has changed by 42.6 million kilometers. These celestial bodies are either approaching each other or moving away from each other. Chemical composition: jacket, 21% silicon, 12.7% iron, 3.1% sulfur. The jacket is impregnated with iron sulfide. The iron content of the metal is low. The core is composed mainly of iron and sulfur. Orbit and rotation: the planet revolves around the Sun in an elongated elliptical orbit at a speed of 24 kilometers per second. Consequently, the distance between them is 206.6 to 249.2 million kilometers. The rotation period is 687 Earth days or 188 years. The Martian day is a solid 37.5 5 to 40 minutes longer than ours. The planet owes these orbital parameters to the gravitational forces of its cosmic neighbors. According to scientists, Mars used to have a more circular orbit, perhaps even less eccentric than Earth's orbit. Mars' axis is tilted 9 to 19 degrees, so the seasons alternate, although their duration varies. Interesting fact, blizzards rage on Mars at night. Wind gusts pick up falling snowflakes, causing real storms. Temperature on Mars due to the lack of a suitable atmosphere. The surface of the planet, which is close to Earth at the point of exit from the solar system and therefore less heated, is very cold. The average annual temperature is -50 to -60 C. There are facts of warming of the poles and equator to +35 C, but this does not change the overall meteorological picture. Atmosphere. Since our cosmic neighbor is a potential host for life, scientists have carefully studied its atmosphere. A lot of interesting things have come to light, but, as is often the case in science, many optimistic predictions had to be abandoned. And here's why. The planet's atmosphere is very rare to 1% of the Earth's atmospheric pressure. On our planet, to reach the conditions of Mars due to the strong influence of the gas-air column, it is necessary to rise to 35 kilometers. The gas shell of Mars is 95% carbon dioxide, but because of its thinness on the planet does not observe greenhouse effect. But there is water, though not in a liquid state. Giant polar caps of H2O saturate the air with water vapor. Scientists are confident that they will find seas inside the planet. It may even be low. Interestingly, the thin layer of the Martian atmosphere completely determines the climatic conditions on Earth. Winds blow there too. Dust storms blow through fog and terrible cold, sometimes up to 150 degrees. Exploration of the atmosphere. Until recently, the main hypothesis about the exploration of the atmosphere from the surface of the red planet was the unproven fact of collision with a cosmic body. Time has made adjustments. In 2013, the interplanetary station MAVEN explored Mars. Much has become clear from the study. Billions of years ago, the planet was hot and humid. There were bodies of water that could easily have been the habitat of living things. 4.2 billion years ago, Mars lost its magnetic field for unknown reasons. The atmosphere leaked out into space. It's still happening today, but at a much lower rate of 100 grams per second. During solar storms, the process of losing the gas layer is greatly enhanced by solar wind streams. If there is no change, our neighbor's atmosphere will disappear into space in a few billion years. The surface of Mars. A rich history of observations and practical research has been accumulated on the surface of the red planet. It is worth dwelling on its stages. Polar glaciers. One of the similarities between the physical and climatic processes on Earth and Mars is the presence of icy continents in the polar regions. Mars' ice cover varies depending on the season. If the north increases, the south decreases and vice versa. The diameter of the stable part of the main zones of the North Pole is 1,000 kilometers. The thickness of the ice shell is 3.7 kilometers. The maximum law field spread reaches 50 degrees south or north latitude of Mars. Interestingly, the Antarctic ice cap begins to smoke when it warms up. Due to the spring thaw, strange geysers are formed, which release streams of carbon dioxide into the planet's atmosphere along with sand, dust and mud. Seas and Manert. The red planet has a special feature, an important difference in the geologic structure of the regions south and north of the equator. The southern part is dominated by hills and has many craters. It is darker, marine. The northern part, on the contrary, smooth, light and low, continents. The reason for this striking difference is unknown. Experts believe that this could be due to the movement of lithospheric plates or due to a cosmic catastrophe. Dried rivers and deep wells. Examination of the Martian soil with special equipment gives the following evidence of its water resources functioning. * Dry river streams. * River channels extending above ground. * The area of the river mouth near the Eberswald crater, an area of 115 square kilometers. Canals over 60 kilometers long. * Minerals formed in water. * Ice deposits. * Fresh traces of salt water. * Remains of dry water flow. * Stones worked by the water. * A subglacial lake beneath the ice sheet, 1.5 kilometers deep. Interesting fact. Wide and deep trenches have been found on Mars. Diameter and length over 100 meters. So without going into geological and chemical details, we can safely say that Martian soil is suitable for agricultural use. This is the opinion of the American expertess. Come out after several laboratory studies. The soil contains all the components necessary for cultivated plant life. Interesting fact, perhaps the most important and game-changing event in space exploration was the extraction of water from Martian soil by the Phoenix landing module in 2008. Why is Mars so named? Mars was named after the Roman god of war because of its red color. This tone really evokes associations with cruel and merciless battles. Later, both satellites of the planet received the names of the sons of Ares, Phobos Fear and Deimos Terror. Also, according to ancient Roman canons, the best time to start a war is March. It is clear where the name of the first spring month came from. Why is Mars red? The cause of the planet's reddish hue is iron oxide. Simply put, rust, which makes up most of the dust. It covers Mars in a layer from a few millimeters to 2 meters Tharsis Highlands. Iron oxide is lifted into the atmosphere by the wind, creating upward currents. It can be seen from space. In fact, the surface of Mars has a whole range of colors: yellow, brown, gold, brown, red, green. It all depends on the chemical composition of the soil. Spectral analysis of equipment on the Mars Express Interplanetary Space Station has provided a definitive answer to a riddle that has tormented the best minds of mankind for millennia. Storms on Mars. Mars' small size, thin atmosphere, and very low pressure combine to create constant winds. The planet is constantly blown by strong currents flying at a speed of 100 meters per second. They reach their maximum in early summer because of the huge temperature difference between the northern and southern hemispheres. The formation of Martian storms involves massive dust streams, which are weakly slowed down by gravity. The strength of the eddies swirling around the surface of our astronomical neighbor exceeds all known limits. From space, only the yellow clouds covering the entire planet are visible. The life expectancy of dust storms varies from 50 to 100 days. Sometimes, when passing perihelion, the closest orbital point to the Sun, the phenomenon becomes global. This happens much more frequently than expected, once every 188 Earth years. Dust devils. There is another interesting phenomenon that resembles an Earth tornado. Dust devils, also known as dust devils. They are dust towers that carry gases and water from the surface of Mars into the atmosphere with their vortices. There are millions of these vertical, violently rotating streams. A tornado occurs over an area of 1 square kilometer every few seconds. All that would be fine, but storms and tornadoes create static charges due to dust friction, which negatively affects technical equipment. During natural disasters, fine grains of sand can enter the device. They also cover the working surfaces of solar panels and optical instruments, thus preventing research equipment from working. Interesting fact, on February 13, 2019, the disintegration of the Opportunity rover, which finally ended the search, was a loss for all of humanity. Interest has been fueled by the latest dramatic report about the device on social media, which says the battery is low and a power outage is imminent. The rover operated on the surface of Mars for 15 years, but storms and cold weather robbed it of its ability to communicate. Mars attractions. Mars is full of unique objects. Some of them are unique in the entire solar system. Would-be travelers will find something on a neighboring planet. Even a simple list leaves a lasting impression. Olympus on Mars. Of course, the most famous landmark is Olympus and its extinct volcano. It is 26 kilometers high and up to 85 kilometers wide. The crater has deepened to 3 kilometers. Mariner Valley Canyons. The canyons of the Mariner Valley are up to 3,000 kilometers long. Its pearl is the deepest gorge up to 8 kilometers high, called the Giba Canyon. The process of its formation is still a mystery. The Night Maze, named after its shape, is a system of canyons, a collection of long dormant Elysian volcanoes, strange morphologic structures, Medusa fossa, spider, lace, channel patterns. Frozen footprints of the fall are craters up to 16 kilometers in diameter. The sediments of the equatorial region are a particular mystery. They don't reflect radio waves. The infinite richness of shapes and landscapes of this unique planet can satisfy the taste of the most sophisticated futuristic artist. And the existing white spots of Mars are waiting for their discoverers. Is there life on Mars? A rhetorical question that has yet to be answered. There are several favorable conditions. Among them, the presence of water. The presence of methane and carbon dioxide in the atmosphere. Fuel saturation with minerals and trace elements. Occasional positive temperatures. Electrical solutions. On the other hand, there are many unfavorable conditions. Due to solar wind and cosmic rays, the planet's surface has high radiation. Radiation levels on Mars are hundreds of times higher than on Earth. Asterisk constant water consumption. Asterisk low average temperature. Asterisk severe weather conditions. Storms, hurricanes, tornadoes. Asterisk chemicals that are incompatible with biological structures. There are no signs of microorganisms on Mars. There's no organic matter on the red planet. Interesting fact, a series of experiments were conducted to grow bacteria, algae and lichens in Martian conditions artificially in laboratories. The results are positive. One microorganism has been able to adapt to the new climate better than Earth's climate. Perhaps somewhere in the caves and crevices of Mars there were or are conditions for the origin of life. The question remains, the past and future of Mars satellites. The astronauts' opinions on the origin of the satellites are conflicting. It may have been asteroids attracted by the planet in the past. Their possibility during the collision cannot be ruled out. Scientists are unanimous about the future. Phobos is in danger of destruction, which could lead to the birth of a planetary ring around Mars. Its components are gradually reaching the planet. Deimos has a different point of view as it gradually moves away from Mars. Interesting fact, long before the American A. Hall discovered Phobos and Deimos in August 1877, their existence was predicted by D. Swift, F. Voltaire. The Anglo-Irish writer, creator of the famous Gulliver's Travels, reported the orbits and rotation times of the satellites in his book. Indeed, not entirely accurate. Grateful descendants wrote down the names of the visionaries and marked them into craters on the surface of Deimos. History of Mars exploration. The Egyptians began observing our nearest cosmic neighbor in ancient times. Later they were joined by the Babylonians, Greeks, Hindus, and Chinese. Arab astronomers also took part. Astronomical treatises and reports of the time focus on simple measurements and regular observations of the planet's movements. Medieval scientists brought harmony to the geometry of the solar system. Copernicus' heliocentric system created the sun and planets. Telescopes began a new phase in the study of Mars. Galileo Galilei was the first to master the technique of instrumental research. His work was continued by Giovanni Cassini, Tycho Brahe, and Johannes Kepler. Huygens and Schiaparelli's maps of the surface of Mars were published. The satellites of the red planet were found and accurate calculations were made. The work of astronomical observatories continues today. The launch of space rockets and equipment brought a new round of research. An era of competition between the Soviet Union and the United States had begun. Interplanetary space stations have been sent to Mars 39 times to explore the orbit, send probes, and Mars rovers. 8 delegations are currently active and 7 more are scheduled to arrive soon. Colonization of Mars between 2030 and 2033. The possibility of sending a spacecraft with a crew is being considered by the US, NASA, Russia's Roscosmos, and the European Space Agency, among others. The United Arab Emirates is developing the Mars 2117 project, a kind of future alien colony of Earth. Many private organizations are interested in the area. Elon Musk, founder of the SpaceX space company, is particularly active. He is actively promoting his business projects with financially promising aspects. The problems and difficulties are many, but the goals are incredibly attractive. Who wouldn't want to be the first human to set foot on Mars? Recruitment of space personnel is already underway. It is possible that some of the future astronauts will be able to repeat the famous small step of Neil Armstrong.